Alright, so in this video we're talking about parabolas, and you probably have seen a parabola before. It's pretty much just a graph of any quadratic function that makes a U-shape like we see here, but now we're going to go in much more depth. Every parabola has a property that any point on it is equidistant, or the exact same distance from a point called the focus, and that's what we see here. Here's a point on my parabola, that U-shape, and it's the exact same distance from a point called the focus as it is from the line called the directrix. Now, you might wonder, what is the focus, what is the directrix? Well, an easy way to think of it is that the focus is kind of the point that the parabola is going to be attracted toward. It's the focal point. So the parabola is always going to be attracted to this focus point. The directrix is kind of like a force field. The parabola is scared of it, so it's always going to run away from the parabola. In other words, the directrix directs the parabola away from it. It's kind of like a sheep herder directing the cows where it needs to go. The vertex is always the lowest point, like we see here in this picture, or the highest point of the graph. A parabola can have its vertex anywhere on the coordinate plane, aka the graph, and it can be oriented so that the parabola opens up or down. Here we see an example of a parabola that opens up, or the parabola can also open left or right. Based on how the parabola is turned, we have different equations. So if a parabola opens up or opens down, then our equation for the parabola is x minus h squared equals 4p times y minus k. Here, h and k is the vertex of the parabola, and its axis of symmetry is vertical. Okay, so if the parabola opens up or down, its axis of symmetry is vertical. This means that the directrix has the equation y equals negative p. Here, p is just a number that controls how wide or how narrow the parabola is going to be. If the vertex is at 0, 0, this is only true if the vertex is at 0, 0, then this should say the focus, not the vertex, then the focus is at the point 0, p. These parabolas open up and down and have their vertex at 0, 0, so the focus is at 0p. Focus is at 0p. So if you know the vertex is at 0, 0, it's very easy to figure out what p is, and that's what we're going to do in the next example. So here we want to, in example 2, we want to identify the focus and the directrix of the parabola whose equation is 3x squared equals y. Alright, so first off, my rule, since I have x squared, that means I have an up and down parabola. And since I know it's up and down, I know my equation for this parabola is x minus h squared equals 4p times y minus k. What I need to do is figure out what is my vertex? Where is h and k? Okay, so that's the very first thing I need to figure out. Where is h and k in my graph that was given? Y equals 3x squared. Well, I'm lucky, since it's y equals, I can just type it in my calculator. So I'm going to clear out all my other stuff, go to y equals 3x squared, and graph. I'm going to do zoom 6 and get a new picture, and this is what it's going to look like roughly. Again, my vertex is always the lowest point or highest point. In this particular picture, my vertex is right here. Looks like 0, 0, but let's have the calculator verify that. So I'm going to do second calc, option 3 for minimum. Minimum is the fancy math name for lowest point. If it was the highest point, then we would use the fancy math name maximum, option 4. It's very important you pick the correct option. Again, for this problem, we needed option 3, minimum. It's going to ask you a couple questions. Left bound, I just need my cursor somewhere on the left side of the valley. Right bound, I just need my cursor somewhere on the right side of the valley. And then yes, I want my cursor where I think the vertex lives, so at the bottom of the valley, enter. So it tells me that my minimum is at 0, 0. I get some decimals here, but I see it's scientific notation, so times 10 to the negative 6 power, times 10 to the negative 11 power. Very, 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 very close to 0, very small decimals. So we're just going to call that 0, 0. So the vertex is at 0, 0. And what that means is that h equals 0 and k equals 0. So I'm going to plug that into my equation now. Alright, so when I plug that into my equation, I have x squared equals 4p y. Well, I want to match this rule up with the rule that I was given in the original problem. I had 3x squared equals y. Okay? What I want to do now is to get my x squares by themselves, because if I can get x squared to match up with x squared, that means everything on the right side of my equation must be equal to 4py, and then I can use that to figure out what p is. So to get x squared by itself, I'm going to divide by 3 on both sides. So that means I have x squared equals y, 1/3 y. Okay? Well, obviously y matches up with y, so that means 4p must match up with 1/3. So 4p must be equal to 1/3. So I can use that to figure out what p is. To get p by itself, I'm going to divide by 4. So p equals, now I have a fraction divided by a fraction. I'm going to do that in my calculator. Remember, my top fraction needs parentheses around it. So my calculator, I have parentheses 1/3 divided by 4. Be sure you type it in the calculator correctly. I get a decimal, let's turn that into a fraction. It's always better to have a fraction if you can. So p is equal to 1/12. As soon as I know that p equals 1/12, I'm going to go back to what I know about up and down parabolas. I know that for up and down parabolas, the directrix has an equation y equals negative p. So that means for this problem, the directrix is at y equals negative 1/12. All I did was plug in my value for p. I also know that since the vertex is at 0, 0, then the focus is at 0, p. So that means for this particular problem, the focus is at 0, 1/12. So we've done everything that the problem has asked us to do. We were asked to identify the focus, we were asked to identify the directrix, and we did that because we first were able to figure out what p is. Okay? We talked about up and down parabolas. Now let's talk about right and left parabolas. And since the parabolas open up right or left, our equation changes slightly. If the parabola opens right or left, this should say right or left here, so fix that on your paper. That's a typo on my part. Its equation is in the form y minus k quantity squared is equal to 4p times quantity x minus h. Again, quantity means it must be in parentheses for this to work. Here, h comma k is the vertex of the parabola. Its axis of symmetry is horizontal. So fix that. That's what you get when you copy and paste. You make lots of typos. This implies that the directrix is horizontal and our directrix is vertical. I really should have just typed this out instead of copy and pasting it from the previous page. And has the equation of x equals negative p. Okay? And if the vertex is at 0, 0, then the focus of the parabola is located at p comma 0. Here's two examples of a parabola that opens up to the right and a parabola that opens up to the left. Also, I know that my vertex is at 0, 0, so since I know that the vertex is at 0, 0 for each of these parabolas, I know for a fact that the focus is at p comma 0. That's only true if the vertex is at 0, 0. Let's do an example. So here we want to identify the focus and the directrix of the parabola that is equal to y squared equals negative 16x. Well, I know, so as soon as I see y squared, that means that I have a parabola that opens up, or sorry, opens right or left. I'm not sure which direction it opens yet, but it does open right or left. Now, I know that my equation, the pattern that I'm going to be using is y minus k squared equals 4p x minus h. The very first thing I need to do is figure out the vertex of this parabola. Okay, so the vertex of this parabola. What I want to do is go to my original problem and I want to graph this. However, I can't graph y squared, I can only graph y equals. So I need to get y squared by itself. So to do that, I'm going to square root on both sides. So I'm going to say plus or minus. Since it's power 2, I've got to square root it. So really my original problem is y equals plus or minus the square root of negative 16x. Okay? Now, what we're going to do, because again, the calculator cannot graph plus or minus, we're going to say y1 is equal to the positive square root of negative 16x. y2 is equal to the negative square root of negative 16x. Just like that. So let's graph these two. So by graphing these two separate graphs, we're going to get the top half and bottom half of a parabola. And together we're going to get the entire picture. So square root of negative 16x and the negative square root of negative 16x. Graph it. And so I can see that based on the picture, this parabola opens to the left and my vertex is at 0, 0. Okay, I can just eyeball that because it's right there, 0, 0. Okay, so since I know that my vertex for this particular problem, vertex is at 0, 0. Since I know that the vertex is at 0, 0, I know automatically that the focus is at p comma 0. Okay, that's the part of the rule that I know since it's a right or left parabola. I need to figure out what p is. Before I can do that though, I'm going to take my pattern and plug in my vertex. Again, h is 0, k is 0. So when I plug in, I get y squared equals 4px. And I want to match that up with my original problem, the original problem. So that was y squared equals negative 16x. Okay? So now, obviously, y squared and y squared match up, x and x match up. What that means is that 4p and negative 16 must match up. So 4p must be equal to negative 16. Well, I want to get p by itself, so I'm going to divide by 4. So p equals negative 16 divided by 4 is negative 4. Okay? Now, so that automatically tells me that for this problem, the focus is at negative 4 comma 0. So we're done with that part of the problem. And we also know that since it's an up and down parabola, or sorry, a right-left parabola, that the directrix is at x equals negative p. Well, so that means that for this problem, the equation of the parabola is x equals negative of negative 4, because p was negative 4. Now I'm going to clean this up, so the directrix has an equation x equals positive 4. So I've identified the focus and the directrix for this particular parabola. And that's it for this video. Parabola Basics, that's all it is.